pay attention to a whiteboard. Today I will be teaching trigonometry and geometric solids. Hey. And go. Class, so let's review what we have learned so far. So what have we learned so far? Yes. Sine, cosine, and tangent. Very good. Alright, now I will write the rules on the board so we can remember them. Sine. S-O-H. Cosine. C-A-N. Tan. T-O-A. So sine, C-O-H. Opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tan is opposite over adjacent. So next.
Maybe we'll have to do, okay, pause. All right, class. Do we have any ideas for this problem? Because
Alright class, do we have any ideas for question number 2? Yes. Can we use the Pythagorean theorem for the AC to find out that final side over there? We'll see about that. I'll explain later. Roll the camera. Hey, Bilal, I don't think that's appropriate. We need to take notes. Let's go. Don't download it. And then, wait, you should report.
Boring!
ah,
Okay, wait.
how could you?
Cut.
The solution to this problem can actually be done by the Pythagorean theorem because we are finding the length of J and we are given these two sides. But the answer I wanted you to use was cosine of 30 is equal to 5 divided by B. And then B is equal to 5 divided by cosine of 30. So B is equal to 5.77. The problem also reads, given the length of, given D equals 9 centimeters, C equals 5 centimeters, and angle ABC equals 30 degrees, find the length of J. In case you class couldn't read the board. Class, so now we have found B and we have to find J. To find J, we can use the Pythagorean theorem. It's a squared plus b squared equals c squared, as you all know. So a is going to be 9 squared plus 5.77, which is going to be b squared, equal to j squared. So 81 plus 3.29 is equal to j squared. J is equal to the square root of 114.29, so J is equal to 10.69. Alright class, we're going to take notes. So we're the angle of elevation. So this is above the horizon line. So now, for example, if this was our angle, this would be the ground, and this would be our line of sight. Okay, for our next note, I hope you have all this written down on the board. We are going to do a similar thing. It's going to be another angle. Now this is the opposite and is below the horizon line. So for example, it's below. Just to remember, if this was our angle, we would have our line of sight over here.
So the door?
Then we would have our angle like this. It would be like that. Class, I hope you all understand this. Alright, pause. Class, we're going to continue our notes. You can find the area of a non-right angle triangle by using the formula. The formula is as follows. A is equal to half AB sine of C. That's AB sine of C if you can't read that, class. And I'll give you 2 seconds to copy that down. Alright. So I have written problem number 3 on the board. Tom is stands 60 meters from the base of a school. From the ground point level where Tom is standing, the angle of elevation to the top of the school is 31 degrees. Find the height of the school. Draw a sketch. Class, so I have written the answer to problem number 3 on the board. So this is the diagram. This is X, where you need to find the height of the school. 60 meters, the angle, which is 31. The school is right here, and so we have to do the tan trigonometric function of 31 degrees. So that would equal to the opposite over the adjacent. So X over 60, you have to multiply the 60 to get to 60. Tan of 31 is equal to X. So X is equal to 36.05 meters. So question number 4, you need to find the area of the following triangle. This side is 14 centimeters, this side is 19 centimeters, 117 degrees, 23 degrees, and I'll give you a hint. You should use the formula I gave in your notes. So for the next problem, I have written the answer to the board. First we need to find this angle, but we have to add 117 degrees plus 23 degrees, which is up here, and that gives you 140, and you subtract it from 180 to get 40 degrees. So this angle is 40 degrees, and we use the formula that I gave you, 1/2 AB sine of C. So we plug in A and B for 14 and 19 and sine of 40 to get 133 sine of 40, so the area is equal to 85.49 centimeters squared. Question number 5, I have, this cube has all edges having a length of 15 centimeters. Find the angle between plane ABFE and plane HGFE. So I have highlighted it in red, and I will expect you to work efficiently. Number 5, I have written the answer. You use the trigonometric function tan of x, and because the side lengths are 15, you do 15 divided by 15 to get 1. So tangent of x is equal to the inverse of 1, so x is equal to 45 degrees. But also, it would have been helpful to draw a right triangle like this, and have A, H, and E over here with X over here. For question number 6, we need to find the length of DC if AD equals 10 feet, AB equals 12 feet, and BC equals 14 feet. Problem class, we need to do 2 sets of Pythagorean theorems. We need to do AB times BC squared to find DB squared, so that's 12 squared plus 14 squared is equal to 144 plus 196, and then DB will equal to 18.43. So then you have this side right here, and then you do DC, which is outlined in blue. So 18.43 plus 10 squared is equal to 340 plus 100. So then you get the square root of 440 is equal to 20.97. That is all I have for now, class. Let's review. What is tan, sine, and cosine?
We already went over this at the beginning of class. Isn't this what he started? This is what you said at the beginning.
I know.
Exactly.
What's wrong with you?
I guess we did go over this at the beginning of the class, so I'm sorry.